In this video, we're going to talk about transfer function, and most probably we're going to solve a couple of examples based on the transfer function, or how to find a transfer function in an electrical circuit. So a transfer function is nothing but it is a ratio of output response to the input excitation. So output usually we represent with y of s, and input usually represented with u of s, sometimes x of s, assuming all initial conditions are 0. So that means if it is a circuit, assuming that initially capacitor is not energized or charged, inductor is not energized. Okay. Now here is this block box is nothing but a system. This is nothing but a system. A system we represent with h of s. So h of s is nothing but a transfer function. Okay. H of s is nothing but transfer function. So h of s represents the system. H of s represents a system, which is y of s over u of s. Now, the transfer function is nothing but a mathematical equation which represents a system. It's a equivalent to representative system, a mathematical equation which is representing a system. A system can be represented by two different transfer functions. I will talk about it in a second. Now, another point is transfer function is independent of input and output. Here I'm saying h of s equal to y of s by u of s, but this h of s is purely independent of these two. This h of s is defined for this system, okay, by using state variables. What are those? We'll talk. Now, a system is a set of things working together to execute a task, or a set of principle or procedure according to which something is done. So basically our government is run by a system. It's not a physical system, but those are a set of rules. Those rules, we're running our government. Same thing if you look at your cell phone, it's a physical system. So there are different components put together to work on a task, to execute a task. That's what a system is. So transfer function represent a system. So for example, here is a simple example. Here is a car. Okay, so this car can have more than one set of state variable, or more than one transfer function. I'll talk about state variables in the next video, but let me talk about transfer function. Now, this is a system. This is a car. Okay, now my output, I care for mileage, okay, or miles per gallon. Okay, and my input for this system is probably I want to spend less money to buy this system. Okay, so my input is like money. Now my transfer function, whatever represent the system, is nothing but output over input. My output is miles per gallon divided by my input is money. That gives this system. Now to relate these two, I need to take set of state variables. Those set of state variables could be like velocity, mass, or number of passengers in the seat or in the car, or those things are the state variables. Okay, now as I mentioned, for the same car, now your requirement is a little bit different than mine. Okay, your output is basically speed, maximum speed. Okay, you care for the maximum speed. Okay, that's your output. Now your input is probably it's a, say you don't want to fill the gas, so you want to have a bigger gas tank, so probably you can take gas as your input. Now for the same system, your transfer function is different. Here your output is maximum speed, your input is gas. Based on this, you're going to have different set of state variables to define this system. Okay, so even though both of them are cars, this car has different transfer function, this car has different transfer function. That's not because of different output or different input. That's because of the state variables you chose to build that system. Okay, now we're going to talk about a simple circuit here. Here we're asking about to find the transfer function. So here transfer function is nothing but V naught over V input, which is nothing but H of S. Okay, this is called output voltage over input voltage. It's called voltage gain. Now first thing we need to do is we need to convert the system into S domain. So it's 1 of S. This is 1 over 0.25 S 4. So can I write this as 4 over S? Now 4 over S and 1 S, they are in series. So 4 over S plus 1 S, they are in series. So it's going to be 4 plus S square over S. Okay, my S look like 5, so don't get confused. Now I want V naught. So can I say V naught is nothing but the voltage across this parallel combination. So let me make this 4 is parallel with 4 plus S square over S. So it's going to be 4 times 4 plus S square over S plus 4 plus S square over S. Okay, so I'm going to do the LCM in the denominator. So it's going to be 4S plus 4 plus S square over S, 16 plus 4 S square over S. Now this S and this S get cancelled out. Okay, now I have 16 plus 4 or 4S square plus 16 over S square plus 4S plus 4. Okay, that's Z of X. So I have, if you look at the circuit, I have 1 ohm resistor. Let me take this as Zx, and my goal is finding transfer function. That's my V naught, and here is my Vn. Okay, so to do this, can I use the voltage division rule? So to get the to find out V naught equal to total voltage Vn times same impedance over total impedance. Okay, so I'm going to use the same principle here. So V naught over Vn, which is the transfer function, equal to Zx is nothing but 4S square plus 16 over S square plus 4S plus 4 over 1 plus 4S square plus 16 over S square plus 4S plus 4. Okay, now I'm going to do the LCM in the denominator. I will end up with S square plus 4S plus 4 plus 4S square plus 16 over S square plus 4S plus 4, 4S square over 16 plus 16 over S square plus 4S plus 4. Now the denominators get cancelled out. We can cancel these two. So H of S, this is H of S. H of S equal to 4S square plus 16 over 5S square plus 4S plus 20. That's our transfer function. I mean, if you want to simplify this, still you can do that, which is S square plus 4 over this is 5 over 4 S square plus S plus 5. That's your transfer function H of S. Okay, thank you.